Hi everyone, welcome to this class on work, energy and power. So we are going to be learning these concepts and I'm going to make the concepts really easy for you. So welcome everyone and welcome to the first class of this new year 2021. So wishing all of you a very happy new year. So hope everyone's doing fine and you guys have made your new year resolution. Excellent. So welcome for this class and I'm super excited to announce that we have a special new year offer for you on our website. So do check out our website because guys, all the courses on our website are at a special discount of 80% off. That's right, 80% off on all our courses, and this is to help you guys with your exam preparation because we know that many of you have your exams coming up very soon. So guys, we have all our physics, chemistry, maths courses for CBSE and ICSE all at 80% discount, and we also have a new Java coding course. So if you're interested in learning computer programming from me, I'm taking live classes there and that's also at 80% off. So guys, I've put the links below. Do check it out after this class if you're interested in taking these courses because I take more live classes on our website. We have interactive videos so you can learn any concept. They're great for revision before exams. And we are also taking mock tests every week. So good evening everyone. Welcome for this class and thanks for joining. And guys, please hit the like button. And as I was announcing here that we are super excited to let you know that we have this special New Year offer. And guys, the New Year offer is only there for 3 more days. So it's valid only till 10th of January. Okay, so guys, do check out the links below and we have all these videos and we are taking mock tests every week to help you with your revision. So you can take these mock tests, attend the live classes, on to understand the solution of the mock tests, revising the important concepts and tips and tricks. So we have the live classes on that, quizzes and questions, and you can also ask doubts. So guys, do check out this website and please share it with your friends. And if you haven't subscribed to our YouTube channel, please hit the subscribe button right now. And please do share it also with your friends. So thanks a lot guys for your love and support and wishing all of you a very happy new year from Manocha Academy. And are you guys excited? Let's begin this class. And I've put the link of the website and these courses below. Okay, so do check out the offer because it's only valid for 3 more days till 10th January. All right, so let's get started with this class on work, energy and power. So I'm going to be discussing the important concepts and we'll be doing some important questions on this topic. So stay tuned. So first let's understand the concept of work. So guys, when is work done? Because we always talk about, hard work, I have homework or I have the work of preparing for my exams. But is that physics work? According to physics, is that work? No. So what is the scientific or physics definition of work? So if you look at this man here, he's pushing this stack of hay, right? So is he doing work? Yes or no? How will you decide that? How do you guys decide that? When will be the work be done? Excellent. So work is done when there is a force and there is a displacement. Exactly. So we talk about work being done when there is a force. So this person is applying a force on this stack of hay, right? Exactly. So when you apply a force and when there is a displacement, very good. So excellent. So when there is a displacement, so if there is a displacement of this stack of hay, then we say that work is done. So what is the key concept here? Work is done when there is force and there is displacement, movement of the object. So if there's no force, obviously no work will be done. And if there's no displacement, there will be no work done. Exactly. So let's talk about what is the formula of, calculating the work done. How do we calculate it, guys? So work done, what is the formula? Fs cos theta. The formula is Fs cos theta. So what does this mean? You basically need to multiply the force, right, times the displacement times cos theta. Okay, so F is the force, so work done, W is force times S, which is the displacement, times cos theta. Now what is this theta? We'll talk about that. Theta is basically the angle between the force and the displacement. Okay, so please note that, guys, theta is the angle between F and S. Okay, so in this case, guys, if a force is being applied on this box and let's say the displacement is in the same direction. So let's say the displacement is from here to here, right? So guys, we can say that force and displacement are in the same direction. Then guys, what is the angle here? Can you guys tell me what is the angle? In this first case, we are talking about, this is our first case, case 1, and then we'll talk about another interesting case here, case 2. So if force and displacement are along the same line, what is the angle? Very good. So Niranjana says 0, right? I see Mamta, General Master, right? A lot of people are saying 0 here. Excellent. So in that case here, the angle is 0. And what is the value of cos? Cos is this trigonometric function. So guys, if you have any doubts, you can search for trigonometry, Manocha Academy, and you can watch all this sin theta, cos theta. So what is the value of cos theta then? Cos 0. So if you look up this table here, I put these tables, and this is very important. You should know all the values for cos theta for 0, 30, 45, 60, and 90, and 180. Okay. So what is the value of cos 0? Cos 0 is 1. Fantastic, guys. So what does cos of 0 or cos theta will turn out to be 1 here. So for case 1, what is the work done? Work done is very simple. Work done is simply Fs, because cos theta is 1. Fantastic. I see a lot of you have written 1 here. Excellent. I want everybody to participate here. And guys, if you haven't hit the like button, please hit the like button right now and do share our channel with your friends. Okay. So W equals Fs. Now let's take a look at this second interesting case. So here you're pushing this block where the force is along this line, right? So force direction is this way, but the displacement is going to be along the inclined plane because the block cannot move this way, right? So it will be along the plane, right? So here, guys, you can see there is clearly an angle. So let me draw the line properly. So you can see that there is an angle between the force and the displacement. Can you guys see that? The angle theta here. Okay. And let's say this angle theta is 30 degrees. So what will be the work done here? So what will be the work done? Again, you apply the same formula, Fs cos theta. So F times force times the displacement and cos of 30 degree here, right? And what is cos 30? As you can see in the table here, root 3 by 2. Okay. So work done will be Fs multiplied by root 3 by 2. So that's why it's good to know all these important tables. Is that clear? These trigonometric tables for all the important values here. Right? Clear, guys? So this is how you do it. Now what if force and displacement are in opposite directions? Then it is 180 degree, right? So there's another interesting case that if their F and S are opposite, so then the angle becomes 180. And so the work done will become Fs cos theta, and cos of 180 is -1, so it becomes minus Fs, right? Similarly, if the angle is 90 degree, right, then you can see that the work done is going to be 0 because cos 90 is 0. So very important to remember this formula, that it depends on force, displacement, and the angle between the force and the displacement. So W equals Fs cos theta. If you know this formula, you can do any sum on the work done. Clear? And please remember this important table. Now let's talk about, potential and kinetic energy. So, energy can be in many different forms. So what are the different forms of energy? Potential energy, kinetic energy, sound energy, right? Chemical energy. Any other forms, guys? So there's so many different forms of energy, right? And energy keeps changing from one form to the other. Now in this chapter, we are going to be focused on the formulas for these two important forms, potential energy and kinetic energy. Very good. Some people are saying heat energy, nuclear energy, electrical energy, excellent, light energy. See, there are so many different forms. Geothermal energy, Rajiv is saying. Excellent, guys. So let's take a look at potential energy. Potential energy means there is a height involved. If we talk about gravitational potential energy. So as you can see in this picture, I'm holding this hammer, right? And you can see the hammer is at a height. So let's call it the height h. Right? So height h, let's say the mass of the hammer is m. And acceleration due to gravity is g. So you can see potential energy formula is mgh. And there's a derivation of this you can see on the book. It's based on the work done, Fs cos theta, right? So you can read the derivation. So important formula for potential energy is, it is mgh. All right. And kinetic energy. So what is potential energy? Potential energy is the energy due to a height, gravitational potential, or in a spring also you have potential energy, which is due to change in configuration, right? So all of you know that potential energy, gravitational potential energy is if something is at a height from the reference level. So here the reference level is the table, and the formula is very simple, mgh. Now what is the what is the formula for kinetic energy, or what is the meaning of kinetic energy? Kinetic energy means when something is in motion. As you can see, this bike is in motion, right? It is the energy due to motion. And what is the formula for kinetic energy, guys? The formula is half times the mass, right? So if this is the mass of the bike is, let's say, m, right? And it's moving with the velocity of v. So let's say the bike is moving with a velocity of v. So then you have the formula half times the mass times velocity squared. So this is the kinetic energy formula. Don't forget the square, okay? Half mv squared. So very, very important formulas. Now guys, can you tell me what is the unit of energy? What unit is energy measured in? So we learned the formulas, mgh, half mv squared, and we'll be practicing some questions, right? So what is the unit of potential energy or kinetic energy or any form? Excellent, guys. The answer is the unit will be joule. The SI unit is abbreviated as J, or you write it as joule, right? So any form of energy, the SI unit is joule. And similarly, guys, do you know what is the unit of work done? So we calculated the formula as Fs cos theta, but what is the unit of work done? Again, the unit of work and energy is the same. Unit is joule. Because they are interrelated. Energy is the capacity to do work, right? So they're like friends. They have the same SI unit, and no matter what form of energy, whether it's sound, mechanical, potential, anything, right? So it is joule, right? Yes, in work done, if you multiply Newton meter, that is basically joule. Exactly. So rather than writing Newton meter, I can see Megha is saying Newton meter, very good. Ayush is saying that, but rather than writing Newton meter, finally we write work done is joule, because work done, right? Energy is the capacity to do work. All right. So they are completely related, that when you do work on a body, energy increases, or with energy, you can do work. Now let's talk about mechanical energy. A lot of people were mentioning mechanical energy, and a great example is an aeroplane, because what is a mechanical energy? It is the sum of potential and kinetic energy. So please remember this, mechanical energy is the sum of the potential energy, right, which we are talking about, gravitational potential energy, and kinetic energy of the body. Is that clear? Right? So when you add these two quantities, you get mechanical energy. Now, why is an aeroplane a good example? Because the aeroplane is flying at a height, right? So when the aeroplane is flying, there's some height involved, there's h involved, right? And obviously the aeroplane is moving, so there's a velocity involved, right? So you can add up mgh plus half mv square, that is the mechanical energy of the plane. Or a flying bird, excellent. I see Gayatri saying flying bird is an example. Raindrop, Ayush is saying raindrop, very good examples, guys. So let's write them down. Flying bird, great example of mechanical energy. Raindrop, right? So mechanical energy is, the sum of potential and kinetic energy, right? Or a kite, very good. Kite is another great example. I think Aniket said kite, very good. So great to see you guys interacting, and please hit the like button. Wow, we have over 300 likes. Thanks a lot, guys. Please hit the like button right now if you haven't. And let's really master the concepts of this chapter, work, energy and power. Okay. So mechanical energy is sum of potential and kinetic, but it is possible that if potential could be 0 or kinetic could be 0, we still call it mechanical energy, right? Though then you can call it potential or kinetic. Okay, very good. I see a lot of more examples like parachute, missile. Excellent. These are all great examples. And somebody said waterfall also, right? So waterfall is also a great example of mechanical energy. Now let's also talk about using the waterfall. Let's discuss energy conversion. So what do we mean by energy conversion? You know that energy it's very interesting. It keeps changing its form from one form to another. So guys, can you tell me what is the energy conversion in a waterfall? So if you look at a waterfall, you can see, right? So water is falling. What is the energy at the top? Can you guys tell me? So what form of energy is here of the water at the top? What do you guys think? What is the energy at the top of the waterfall? Potential energy. Fantastic. Excellent, guys. So you can see clearly there is potential energy at the top. Why? Because there's a height involved, right? Clearly you can see there is a height of the water, right? Water has some mass. There's a height, mgh, right? And as the water falls down, what is happening to that? The height is decreasing. So potential energy is clearly decreasing. Does that mean the energy is getting vanished? No. The energy is getting converted, to some form. And what is it getting converted to? Very good, guys. As it's falling down with the velocity, it's getting converted into kinetic energy. So clearly you can see there is a conversion from potential to kinetic. Same way, when you drop the hammer, right? So when I drop this hammer, originally the hammer was at a height, h. So it had potential energy. Now when it falls on the nail, it falls with some velocity, right? So clearly it is kinetic energy here. So all the time you can see, energy conversions are happening. In these cases, the simple one, potential to kinetic. Okay, awesome. So now let's also discuss about law of conservation of energy. Just like we have law of conservation of mass. Do you guys know the law of conservation of energy? What does it say? So law of conservation of energy, basically, let's discuss it I'm going to make it really easy. Let's discuss it with this simple example. Let's say the potential energy, okay, of a certain amount of water. Let's say we are talking about 1 kg water or whatever. The potential energy of the water, let's say at the top is, just for an example, let's say it's 100 joules. Okay. So potential energy of a certain amount of water at the top of the waterfall is 100 joules. Now, as this water is falling down, it is getting converted into kinetic energy, right? So potential is decreasing and it's getting converted into kinetic. So clearly we know that right at the bottom, the potential energy will be 0. At the base of the waterfall, right? It's going to be 0. So guys, can you tell me how much kinetic energy will the water have at the base? So what will be the kinetic energy? Because potential will be 0. So how much kinetic energy will we have? Very good. I can see a lot of you are writing the law of conservation of energy. We'll talk about the statement, right? So what will be the kinetic energy? Very good. I see one has written 100. Don't forget the unit, guys. Okay. Top of the world is written 100. Excellent. So Neha has also written 100. Very good. So the answer will be 100 joules, right? Because what happens is the potential energy at the top gets converted into kinetic energy, because potential energy keeps decreasing and the energy is not wasted away. Okay, so we are ignoring the heat loss and all that, right? So the potential energy here is being converted, you can see, to kinetic energy. Potential energy is getting converted to kinetic energy. And what does the law of conservation of energy say? Excellent, guys. Like you guys wrote, energy can neither be created nor destroyed. It gets converted from one form to the other, right? So you cannot create energy, you cannot destroy energy. It's a very interesting guy. It's always changing its form. Okay, right? It's always transforming. So here, if you had 100 joules of potential energy at the top, it will slowly get converted into kinetic. So when potential energy becomes 0 at the base of the waterfall, the kinetic will be exactly equal, 100, not 99, not 95, not 105. So kinetic, the energy will not increase or decrease. Is that crystal clear? Awesome. So this is the law of conservation of energy, and you can apply it to swing, pendulum, anything. Of course, we are ignoring the loss in heat, and but that is also not a loss, right? It's getting converted to heat energy. Awesome. So now let's move on to a very important theorem called work energy theorem. So a lot of students get confused with this, and let me make it crystal clear to you. Okay. So what does the work energy theorem say? It basically says that the work done, as you can see here, work done is equal to the change in kinetic energy. So what does that mean? So let's say you have this block here, right? And you're pushing it with a force, right? So you're applying a force on this block, and let's say the initial velocity, right? So let's say the initial velocity is u, and you keep applying a force on the block, and the final velocity is, let's say, v, right? Because when you're applying the force, most probably the velocity is going to increase, right? So guys, do you agree that work is being done here? So why is work being done? Because there is a force applied, and clearly you guys can see there is a displacement of the block, right? So work is being done. Yes, all of you agree? Work is being done, and we can say that work done, you can calculate it in one simple way. The work done is basically F multiplied by S, because here the angle is 0. It's in the same direction, right? So work done is F times the displacement S. We are using the formula Fs cos theta. But the work energy theorem says a very interesting thing. Work done is not only Fs, it is also the change in kinetic energy of the body. Now, what do we mean by change in kinetic energy? Change in kinetic energy basically means final kinetic energy, because always change means final minus initial. So final kinetic energy minus the initial kinetic energy. Do you guys agree? Now, what is the final kinetic energy? Let's use the kinetic energy formula that we discussed. Half mv square, half mass times velocity square. So if you apply it here, what do you get? Half mv square, because v is the final velocity here, minus the initial kinetic energy is half mu square. So this is what the formula becomes. So not only you can calculate work done based on Fs cos theta, you can also say the change in kinetic energy of the body, right? So like when engine does work on the car, right? There's a force and displacement, and it's increasing the speed of the car or the velocity of the car. So we can calculate it also using half mv square minus half mu square. Okay, and these concepts will become very clear when we do some numericals also. Okay, so this is the very important work energy theorem and very useful. Now let's talk about another important concept called power. Okay, right? So here, we sometimes say lion is a very powerful animal, but here what are we talking? Power means we are talking about the physics power. And what is the physics definition of power? It's basically the rate of doing work. Rate of work done or rate of doing work. So what do we mean by that? Whenever you see this word rate, it means divided by time. Okay, excellent. So I see Isha Gautam has written rate of doing work. Very good. So what do we mean by that? Right, as Niranjana is saying, work divided by time, because rate means divided by time. So what is the power? It is work done divided by the time. Clear? Awesome. So let's take this example. Let's say you have this crane. Can you see that it is doing work in lifting this load? Why? Because there is a force involved. There is a force involved. And there is a displacement involved here, right? So there will be a displacement also, force and displacement. Now we are interested to know not only what is the work done, how fast or slow is the work being done. That means we are dividing it by time. Is it taking 1 minute to lift the load, 2 minutes, 5 minutes, right? And the faster it lifts it means more power, because divided by time. Okay, so excellent, right? So you can calculate the work done, Fs, right, divided by the time taken. T is the time taken here. So time is also involved. So if you apply this formula, so we can write work is basically Fs divided by T. Now guys, if you look at this, can you guys tell me what is S divided by T? If you focus on this part, what is S divided by T? So can you guys tell me what is displacement by time in physics? Fantastic. Velocity. I see Deepti has the right answer. Better we say rather than speed, let's say velocity, right? Because displacement is a vector, velocity is a vector. Awesome guys, you guys rock. So this means displacement by time is velocity. So we can say the power formula, another very interesting formula is F into V, right? So we can say power is not only work by time, we can also say it is force times the velocity. As you can see, it's written here. So these are the two important formulas for power, right? Power, remember, work divided by time or force times the velocity. And very simple to derive. Fs by T, S by T is velocity. Awesome guys. And now guys, can you tell me what is the unit of power? So who can tell me? So guys, what is the unit of power? Who can give me the answer? So the answer is there in the question itself. I'm saying what is the unit of power? So it's not, so is it WHAT? No, this is not the unit. The unit is WATT, right? Excellent guys, excellent. You guys all writing it? Correct spelling, and the abbreviation is capital W, right? So like you've seen, you know, the power of a light bulb, it's written 40 watt, 60 watt or 20 watts, right? So what is the unit of power? So which is basically joules per second, right? Because you know this unit is work by time, so that's going to be joules per second, and that is nothing but watt. Awesome. Now let's talk about another interesting thing. So, you know, when you have this power, you want to measure the amount of energy consumed. Like, you know, the electricity bill is on the amount of energy you've consumed. And recently I put a video on that. You know, you can watch that video on this commercial unit of energy, how your electricity bill is calculated. Because remember guys, what is the electricity bill based on? It's not based on power. It's based on the amount of energy that your house is consuming. Okay. So let's talk about this commercial unit, that how do they bill us, right? So just like we learned that power, right? Power is work by time. Or we can say, because work and energy are the same thing, work done changes to energy. So we can say it is energy divided by time. So now if you cross multiply here, you will get this formula, right? Can you guys see that? So let me write it to this side here. Since power is energy divided by time, energy is nothing but power multiplied by time, right? Energy is power multiplied by time. Okay. So with this help, you know, we can talk about the commercial unit of energy. Because why do we have this commercial unit? Because the reason is joule is too small a unit. The SI unit is a very small unit of energy. So rather than measuring in joule, we measure in kilowatt hour. So what does that mean, this unit kilowatt hour? Let me explain it in a very simple way. Let's say you have an air conditioner like this, right? So let's say we have an air conditioner of 1000 watts. And this air conditioner is used for 1 hour. All right. So what is the energy consumed by the air conditioner? So let's use the formula, right? Energy we know. So energy guys is power multiplied by time. So what is the power of the air conditioner? 1000 watts, right? Multiplied by the time is 1 hour. But rather than converting the hour to seconds, you know, because rather than doing, if you convert it to seconds, you know, it's going to be very big, like 3600 seconds, right? 16 to 60 seconds. So that's going to be a very big unit. So we won't do that. So we'll be smart here. We'll keep it as 1 hour. And so what do we get? 1000 watt is nothing but 1 kilowatt. Because 1000 watt is 1 kilowatt multiplied by 1 hour. So what is the energy consumed by this air conditioner? It is 1 kilowatt hour. And this is the commercial unit of energy. Electrical energy. Commercial unit. So see, the number becomes so small rather than, 3600 into 1000. So getting into some big numbers, we are saying the energy consumed by this air conditioner, let's say it's blowing the breeze on my head right now. So the energy consumed, if I turn it on for 1 hour, what is the energy consumed? 1 kilowatt hour. Okay, very good. Some of you are asking, what is horsepower? Okay, so horsepower is a more older unit. That is not the commercial unit. So great question. Horsepower is the measure of power. And what is that? Let me explain that to you. So horsepower, the conversion is 1 HP. So it's used, usually for the cars and motors, right? 1 horsepower is 746 watt. Okay. So what is the important difference here? Watt and horsepower, they are the units of power. But here we are talking the commercial unit of energy, because the SI unit is joule, right? Joule is the SI unit. But joule is very small to measure. So rather we measure it in kilowatt hour, or what is famously known as unit. And so if your house, let's say, consumes 10 kilowatt hour and the bill is 5 rupee per kilowatt hour, the bill will be 50 rupees, 10 times 5. So this kilowatt hour is popularly known simply as unit, the commercial unit. Is that clear? So how will you remember this kilowatt hour concept? Just remember with this simple air conditioner example. If you run an air conditioner of approximately 1000 watt or 1000 watt, which means 1 kilowatt, right? Because 1000 watt equals 1 kilowatt, and you run it for 1 hour, then the energy consumed by it will be power into time. So it will be 1 kilowatt hour. Is that clear? And exactly the electricity bill is measured on this unit. So as I explained, if your house consumes 10 kilowatt hours, let's say in a day or something. So if it's consuming 10 kilowatt hour, which is basically 10 units, and if you multiply that by, let's say, 5 rupee per unit, so what will the bill be? It's basically going to be 50 rupees for that day. Okay, so that's how you work it out. Awesome. So guys, now we have revised the important concepts of this chapter. So let's go ahead and practice some numericals so that the concepts will be crystal clear to you. So here's the first question. What is the work done by the force of 100 Newton if the displacement of the box is 40 centimeters and the angle between the force and the box is 60 degrees? So come on guys, I want you to pick up your pen and paper and let's solve these questions together. And great to see that we are reaching almost 500 likes. That's awesome guys. So thanks a lot, and please hit the like button. And as I said, a big happy new year to everyone. This is the first class of the new year in 2021, my first YouTube live class. And guys, do check out our new year offer. We have this special new year offer where all the courses on our website are at 80% off. That's right, all courses. And this offer is only valid for 3 days. It'll expire on 10 January. So do check the links below. So let's go ahead and do this question. All right. Chemical bonding, you want the video, you can just search chemical bonding Manocha Academy. That's already been uploaded. So do check out that video. All right, so let's go ahead and try this. The work done by the force of 100 Newton. So let's write down the data quickly. So the force is being applied on this block, right? And the force is 100 Newton. And it says the displacement of the block is 40 centimeters. Okay. But the angle is given, right? So there is an angle between the force and the displacement. So let's say, if you want an angle, maybe we can take the force this way. So let's say it's being pulled by a string like this, and let's say the displacement is this way. And displacement is given to us as 40 centimeters. And what is the angle here, guys? The angle given to us is theta is basically 60 degrees, as you can see here, right? So come on, guys, let's go ahead and work out this answer. What will it be? So what is the important formula to use here? Remember, we did work done is Fs cos theta. Please remember that, Fs cos theta. Wow, thanks a lot. Great to see more than 100 likes. So let's go ahead and solve this question. Awesome. Thank you, guys. So what is the work done? Work done is Fs. So let's write that down. Fs. I'm using the same colors for these. and cos theta. So now you just substitute. So 100 Newton, we are going to put it here, 100 multiplied by S. Now that's 40 centimeters. So guys, don't forget to convert it to meters, right? So this is basically 4 by 10 meter, right? If you divide by 100. So that's 4 by 10 meter and multiplied by, what is cos of 60? That's why I said it's very important to learn this table. So as you can see from this table, cos of 60 degrees half. Excellent, half. I see a lot of you writing half. Fantastic, guys. You already know the table. Otherwise, you can watch my trigonometry video, right? Just search on YouTube or on our website. And if you multiply this is what you get. So what are we going to end up with here? So please multiply these numbers for me. So 100 times this, so the 0 is going to cancel here, right? And the 2 and this will cancel. So I think I'm getting work done is 20. And what is the unit of work done? Joule. Okay, don't forget. The unit of work done is joule. So are you guys getting the answer? Please check. I'm doing it live in case I make some calculation mistake. Awesome. I see Praveen Kumar has got 20. Aniket has got 20. Fantastic. Angad. Don't forget to write joule. Okay, unit is very important. In physics, don't forget the units. 20 joule. Excellent. Let's go on to our next question. A boy lifts a box of mass 4 kg to a height of 150 centimeter. What is the work done by the boy and how much energy does the box gain? Very interesting question. Let's take a look at this. So the mass of the box is given as 4 kg. Okay. And it's lifted to a height of 150 centimeters. So the height here involved is 150 centimeters. Okay. What is the work done by the boy? So height, or we can say displacement. Same thing, right? So 150 centimeters. What is the work done? Again, let's use the formula Fs cos theta. So now here no angle is given. So we are going to assume that the force and displacement are in the same direction because he's lifting it. So the force will be upwards and displacement clearly is upwards, right? So theta is 0 degree here. All right. Now guys, what is the force here? So force is basically the weight of the box. Do you guys agree? And so that's going to be equal to mg, right? It's not going to be 4 kg. It's going to be m into g. So be careful about that. And displacement is given as 150 centimeters. So we have to again convert it to SI unit. Okay. So guys, let's do this carefully. So if we substitute, W is basically, F is basically mg multiplied by S, and there's no cos theta. So it's mg into S. All right. And so let's substitute the values here. Mass you can see is given as 4 kg. So let's put it down. So 4 and G I'm going to take approximately, right? We'll take the simple value of 10 meters per second square. You can put 9.8 also, you know, if your school says you have to use the accurate value, but we'll make the calculations easy here. So 4 times 10 times the displacement. And displacement, guys, please remember it's 150 divided by 100, right? We have to convert it to meters. So what do we guys get here? 4 times 10 times 15 by 10. So this will cancel and basically I'm getting work done is 60 joules. Are you guys getting that? Awesome. I see Oja has got 60. Fantastic. Oh wow, some of you have got the more accurate answer with 9.8, 58.8. Fantastic, guys. You can use 9.8 if your school says that. So answer is 60 joules. Excellent. Now what is the energy gained by the boy? Who can tell me that? What is the energy, sorry, not by the boy, by the box. So energy gained by the box. How much is that? Who can give me the answer of this one? Very good. Jayanti, Arush, Suhail Ahmed, Darshan. Fantastic. Gautam Das, it's 60 joules. Because why? What is the concept? Energy gained is equal to the work done. As simple as that, right? Because how much work you do will get transferred into potential energy of the box. Right? So it's getting converted. Excellent. So the answer is going to be the same, 60 joules. You guys are rocking. Awesome. Clear? So exactly, very important concept that the work done is going to get converted into the energy gained, right? So work done is getting converted into energy gained by the box. Awesome. Next, we have a very interesting question. what is the work done by the earth, right, in moving around the sun? Or we can say work done by the sun on the earth, right? So what is the work done when the earth moves around the sun? And all of you know, the earth is going around the sun, right? So all of you know this, that it is revolving around the sun. So how much work is being done, guys? So let's take a look. Always when you're looking at work done, remember Fs cos theta. So what is the force involved here? Force is the pull, the gravitational pull of the sun on the earth. This is the force. Now what is the displacement? Displacement, guys, you can see is going to be in this direction, right? Because it's perpendicular. It's a tangent to the circle, right? So you can see that, right? And so now if you see what is the angle between the force and the work, displacement. So you can see force is the gravitational pull of the sun and displacement is a tangent, right? It's a tangent to the circle. So at this time, the earth is moving this way, guys. Do you guys agree? At this point, the earth is getting displaced this way. At another point, it will be another tangent to the circle, right? So what is the angle between the force and the displacement? Awesome. You guys gave the correct answer. It is 90-degree angle. Excellent. So the angle you can see is 90-degree between the force and the displacement. So what is the work done? Work done is Fs cos theta, right? Fs and cos of 90-degree. What is cos 90? A big zero, right? So fantastic. Fs multiplied by 0. So the work done is 0 is the answer. 0 joules. No work is done. Why? Because force and displacement are perpendicular to each other. 90-degree. Awesome. Another way to think of this question is, so this is the better way to answer it. Another way you can think that when the earth goes around the sun at the end of the year, what is the displacement of the earth at the end of 1 year? Can you guys tell me at the end of 1 year, what is the displacement? Again, the displacement, very good. Arsh has written the correct answer, 0, right? 0 displacement, Raghuram is saying, fantastic. So at the end of the year, the earth comes back to the same position. So if you look at the work done throughout the year, the sun is doing no work, right? Sun will be really angry to hear that, that I've done 0 work at the end of the year. But according to physics, right? So we physics guys are making the sun angry here. The work done is 0. Because at the end of the year, the displacement is 0. But this is the recommended way to answer it, that we don't have to wait for the whole year to analyze the displacement. You just say that the centripetal force, the gravitational force pulling the sun is perpendicular to the displacement at any point of time. So work done is 0. Awesome, guys. Excellent. So let's go on to the next question. And guys, if you haven't hit the like button, please hit it right now. Great to see we have around 580 likes. Thanks a lot, guys. I'm really happy for this, and a big happy new year to all of you. And also do share our channel and our website with your friends. Cos theta. So what is cos theta? That's why I'm saying please watch my video on trigonometry. You can search for trigonometry, Manocha Academy. So sine cos. So cos is basically, there are these trigonometrical ratios based by hypotenuse of the right angle triangle, right? And so you have to learn these cos values. So those are usually concepts I think coming next year for you in class 10. But better you learn this table from 0, 90, and I've also given the 180-degree value. Very important because it's -1. And thanks a lot, guys. Great to see above 600 likes. Wow, you guys are really making my New Year special. And so let's go ahead to our next question. This is very interesting. If the mass and velocity of a body is doubled, how does the kinetic energy of the body change? So what do you guys think? As I said, to understand what is cos theta, I won't be able to explain it in this class in detail. Please search for Trigonometry Basics Manocha Academy, okay? And you'll see the video on that. So let's take a look at this. So remember, we are dealing with kinetic energy here. So mass and velocity is doubled. So my technique of doing this question is first think of what is the original thing, right? So initial, what is the initial situation? So we can say the initial situation is we can call it kinetic energy 1. So KE1 is basically half mv squared. Okay, now we can say after the change, right? So what is the new or the final kinetic energy? It is basically KE2. We can call it KE2. And here instead of mass, we know that the mass is doubled. So we are going to substitute 2m here. Do you guys agree? Okay. And velocity is also doubled. Okay. So instead of v, I'm going to substitute 2v. But guys, don't forget to put 2v inside the square because it's 2v whole squared. Okay. So if you simplify this one, what do you get? Half times 2m times not 2v square. It's going to be 4v square because 2 square times v square. Right? Do you guys see that? This is very important. This part is basically nothing but 2 square multiplied by v square. Exactly. So what do we get here? So we are basically getting half, and if you leave the half alone because there's half in the original one. So you're basically getting half times 8 mv square. Do you guys see that? Yes or no? Half times 8 mv square. And now how do you compare it? Very simple technique. Just find the ratio, right? So very important tip, guys. Just go for the ratio. That's all. So what is the ratio? Ratio is going to be KE2 by KE1. And what do we have there? We have half 8 mv square divided by half mv square. So you can see the half will cancel. Mv square will cancel. And what are we left with? 8. Do you guys see that? So the answer is going to be 8 times, not 4 times, guys. Please take a look. Please check my calculation. In case I made a mistake here, you can see 2m is the mass is doubled and the velocity is also doubled. So there's a factor of 2v square. So the correct answer is going to be 8 times is the answer. Do you guys agree? The ratio is 8:1. Exactly. Awesome. So you just have to take, KE1 half mv square, KE2 and just substitute this. And how do you compare it? Just simply find the ratio of KE2 by KE1 and just do the simplification. You will get the answer as 8. All of you getting 8 times? Awesome. I can see a lot of you. Sudhakar says 8 times, right? Praveen Kumar is saying 8. Now some of you are still saying 4. No guys, please check. The trick here is it is 2v square and this half and half will cancel. So don't think that this is half times 8 mv square. It's 4 mv square. No, but KE1 is half mv square, right? So be careful, right? Awesome. Let's move on to our next question. You guys are doing great. A body of mass 2 kg is dropped from a height of 10 meters. So in physics, always draw a diagram to visualize. Okay. If a diagram is not given, please guys, draw a diagram. So let's say we have this body of mass 2 kg. And it is dropped from a height of 10 meters. So this height is given to us as 10 meters. All right. And let's say this is the ground level. Okay, so I'm not a great artist. I'm just sketching this for you, but make sure you draw a rough diagram. Now, what do we need to do? Find the potential energy and kinetic energy of the body halfway down. So halfway down means somewhere over here. And that basically means the height involved here is 5 meters. Right? Do you guys agree? So how do we do this question? Very interesting. Find the potential and kinetic energy of the body halfway down. So potential energy halfway down should be pretty simple, right? So let's find the potential energy first at this point. So we can call this point number 1, right? This is our point 1 and this is the point 2. So let's find the potential energy at halfway down, right? So halfway down, what will be the potential energy? Potential energy will be mgh. Right? We can say this is potential energy 2 because it is at point 2. Now just multiply the numbers. Mass is given as 2 kg. G you can take approximately 10 meters per second square or 9.8, right? And what is the height? Height is 5 meters. So if you multiply this, what are you guys getting? Very good. I see Sunana has got 100. Excellent. Okay. Archana has got 100. Very good, guys. Okay. So if you multiply this, you're going to get 100 joules. So the potential energy we have found at halfway position is 100 joules. So this part is done, right? Now we need to find the kinetic energy halfway down. So how are you guys going to do that? How will you find KE2, means at this halfway down position here? So one option is, we can go for half mv square formula. But the problem is we don't know the velocity. So we might have to use equations of motion to find it. But I'm going to show you a much better technique than going for equations of motion. So what is the technique here? We are not going to use equations of motion. You can do that. You'll get the same answer. We are going to use the law of conservation of energy. Okay. So what is the trick here? Rather than finding the kinetic energy directly, we are going to say, what is the energy at point 2? Right? So let's say this. So total energy at 2 is basically PE2 plus KE2. Do you guys agree? Right? That's the mechanical energy. Very good. And what will that equal to? The total energy at the top, right? So what is the total energy at 1? That is simply PE1, because the ball is just dropped. So here you have at the top, you will have only potential energy, no kinetic energy, right? Are you guys getting that? So at the top, there's only potential energy. So if we multiply, what do we get? M, G, H1. This was H2, right? So if you multiply these numbers, what do you get? The mass is basically 2 kg times 10 times the height was 10 meters. So total energy at the top was 200 joules. Or we can say this is the potential energy at the top, right? So how much will be the kinetic energy halfway down? Because by the law of conservation of energy, excellent guys, a lot of you have got it. So using law, please write that, right? Law of conservation of energy, right? So we're going to use that. We can say that the total energy at E1, so total at E1 will be equal to total energy E2. And what is the total energy at the top? 200 joules. What is the total energy at E2? It's basically PE2 plus KE2, right? So therefore KE2 is nothing but 100 joules also, because potential energy is 100 joules. Did you guys get that? So that is our final answer. So isn't that awesome? We have used exactly, very good, 100 joules. So we didn't go for equations of motion. You can do that. You can find the velocity, v square and all that. But we went for law of conservation of energy, that the energy at the top is going to be at the energy at halfway down. And so to find the energy at the top is very easy. Only potential energy. The ball hasn't started. The body hasn't started moving. And this is how you calculate it. Superb. Awesome. Right? Excellent, guys. Next question. Wow, we have more than 700 likes. You guys have really made my New Year special. Thanks a lot. Let's go on to our next question. Very interesting question. Velocity of a vehicle of mass 1 ton. It increases from 20 meter per second to 30 meter per second. Find the work done by the engine. Okay. So first very important thing always in physics, write down the data. What is our data? Mass is 1 ton. Now guys, can you tell me 1 ton is how many kg? Because SI unit is kg. So can you guys, who can tell me? 1 ton is how many kg? Thousand kg. Fantastic. I see. Very good. You guys have the right answer. Excellent. Mass is 1000 kg. 1 ton, because 1 ton is 1000 kg. And the initial velocity is given to us as 20 meter per second. U is 20 meters per second. Final velocity 30 meters per second. Right? Now find the work done. So it's asking the question, find the work done by the engine, right? Because the car is moving. So what is the work done? So work done, we have learned this formula, Fs cos theta. Now is force and displacement given here? Can we use this formula, Fs cos theta? What do you guys think? Wow, some of you are already ready with the answer. So let's try it out. So can we use Fs cos theta here? We can't, right? Because we have not been given the force. We don't know the displacement. So this formula won't work, right? This formula won't work for us. So what do we do now? So don't panic, right? Very simple. As I said, there's another very important theorem we talked about, work energy theorem. Work done equals change in kinetic energy. Very good. As Meena says, we have to use work energy theorem. Excellent. So use the work energy theorem, which says work done equals change in kinetic energy. So we're going to apply that, right? Because Fs cos theta won't work. So we'll go for the next one. So by work energy theorem, right? So work done equals change in energy, which is basically half mv square minus half mu square, change in kinetic energy, right? So now you just simply apply it. We can take half m common, and what do we get? V square minus u square. Okay, so let's go ahead and substitute. Now v square minus u square, you can do the trick, a square minus b square, v plus u times v minus u, right? So let's make the calculations easy. So half times 1000, and we are going to do v plus u here. So what is v plus u? 30 plus 20 multiplied by 30 minus 20. And guys, can you calculate this for me? Okay, so very important application of work energy theorem. Excellent. I see Sudhakar as the correct answer here, right? What is the answer going to be? So if you multiply all these numbers, I think we are going to get the work done, right? So if you do the calculation, work is basically going to be, so this is a 50 here and a 10 here, right? So I think you're going to get 250,000 joules. Are you guys getting that? Please check. 250,000, excellent. So you can write it in terms of kilojoules, right? 250 kilojoules is the final answer, work done. Awesome. Exactly. So what is work energy theorem? As we discussed, not only work done is Fs cos theta, work done is change in kinetic energy, because when you do work on a body, you're changing its kinetic energy, right? Half mv square because work done is transferred as energy. So half mv square minus half mvu square. Why did we apply this formula? Because no force, no displacement was given. So obviously we have to use this, right? And that is why we went for this formula. Awesome. Excellent. Let's try another interesting question. A man of mass 50 kg runs up the stairs in 10 seconds. If the height of each step is 20 centimeters and number of steps is 30, what is the power of the man? So can you guys try this question? So how do you calculate this? Again, write down the data. So let's say, we have this man and he's running up the stairs. Okay. So he goes up this flight of stairs, right? And so let's write down all our data. Mass is given 50 kg, right? Time is given as 10 seconds. So you can see mass is given to us. Time is given 10 seconds. Height of each step is 20 centimeters and number of steps is 30. So what is the displacement, guys, of this man? So displacement is basically going to be 30 steps into 20 centimeters, right? Which is basically 600 centimeters. Now, if you divide by 100, because we want to convert to SI units, 6 meters. Do you guys see that? Right? So what is the power of the man? We want to find the power. And remember, power is basically work done divided by time. So what will be the work done by the man? So work done, you can think in terms of potential energy, because clearly he's changing his potential energy. So work done, so either you can think energy by time, or you can think in terms of force, right? Force and displacement. So whichever way you think, you're going to get the same thing. Work done is basically energy by time here. And what is the energy involved? It's potential energy, right? So energy clearly involved here is mgh. His potential energy is increasing. Or if you think of what is the force? The force is his weight. Another way to think of the work done is the force is his weight, force is mg, and the displacement is the height h. Okay? Do you guys see that? So instead of s, maybe I can write h here for the height. So whichever way you think, you guys are going to get the same thing. So let's go ahead with E equal to mgh. And so what are we going to get here finally? Power is mgh by t. So let's substitute our values. The mass is given as 50 kg, g is 10 meters per second square, height is 6 meters, divided by the time is 10 seconds. So what is the final answer you guys are going to get for power? So this is going to cancel, 10 will cancel, and we are getting 50 times 6 is going to be 300. Should it be 300 joules here? What will be the unit? The answer is not going to be joules. It's power, not work done or energy. Be careful. Joules per second, and that is basically the answer is watt, right? The unit of power. So this is our final answer here. So all of you got how we did that? Very simple. Wow, we are over 770 likes. Thanks a lot, guys. If you haven't hit the like button, please hit it right now, and do share our website and our YouTube channel with your friends. As I said, I'm super excited to let you know we have this special New Year offer for all of you because you have your exams coming soon. So at Manocha Academy, we have put all our courses on 80% off. That's right, all courses, physics, chemistry, maths, computers. So guys, do check out our website. Links are given below, and this offer expires in 3 days on 10th January. So you'll get more live classes, interactive videos. We are taking mock tests for your revision, and quizzes, questions, you can ask doubts. So a lot of good stuff on this website at a great price. And thanks a lot for 800 likes. Wow, you guys have made my new year really special. So big thanks from our team. And let's go ahead to our next question. An electric bulb has a power of 100 watt. How much energy does it consume in 1 hour? So very interesting question. Okay, so electric bulb has a power of 100 watt. And how much energy does it consume? The time is given as 1 hour. So what do you guys think we're going to do here? So what formula will we apply? So guys, we know that power is work by time or energy by time. So therefore we can say that energy is power multiplied by time. Do you guys agree? Okay. Wow, more than 800 likes. Thanks a lot, guys. Let's go ahead and try this. You guys are rocking and awesome, and this session has been really interactive. Thanks a lot. So let's try this question. How do we work it out? So energy is power into time. Power is given as 100 watts, right? So 100 watts multiplied by 1 hour. Now, one interesting thing is you can calculate, because it doesn't say SI units. So maybe we can calculate it in kilowatt hour, right? So how much is 100 watts? It's nothing but 100 by 1000 kilowatt multiplied by 1 hour. So what is the answer you're going to get? So these zeros will cancel, and we are going to get 0.1 kilowatt hour. So this is our final answer. The energy consumed is 0.1 kilowatt hour. Do all of you see that? Awesome. And if you want to convert it to joules, you can do that as well. Some of you are writing the SI unit answer. Absolutely fine. So energy will be, but there's more calculation involved there. 100 watts, right? Multiplied by 1 hour is basically 16 to 60 seconds, right? So if you multiply all these numbers, you're going to get 36 and 1, 2, 3, 4 zeros. Are you guys getting that? 36, and there are going to be 4 zeros. So you can write 10 to the power 4 joule. This is the energy. So both these answers are correct. One is in joule and one is in the commercial unit that we talked about, kilowatt hour. Awesome. I see Ganesh has the correct answer in joules. Excellent. So this is how you do it. So you can write the answer in kilowatt hour or joule, but if it says SI unit, you must write this. So please remember, guys, this is the SI unit. Okay. And this is our commercial unit, kilowatt hour. So this is how you do these questions. Main concept, energy is power into time. Where am I from? So I am from Kolkata in India. So, and my name is Sandeep Manocha. So a big happy new year to all of you guys. And this class is going awesome. Wow, 840 likes. Wow, this is great. And let's try another very interesting question. An object of mass 1 kg is dropped from a tower of height 50 meters. Draw the graph of mechanical energy versus distance from the top as the object falls down. So very interesting question. What's going on here? So you basically have a tower, and let's say a ball or a body, right, is dropped from the top of the tower of mass 1 kg, and we need to draw the graph of mechanical energy as the object falls down. So guys, mainly think about this as the distance from the top is increasing, right? So this is our distance from the top. As it's increasing, how do you guys think, how is the mechanical energy of this body changing? What do you guys think? So as the body is falling down, and remember, hint is mechanical energy is potential plus kinetic energy, as we discussed today. So what do you guys think? How will the graph look like? Will it be a slanting line? Which way? So main thing is, how will the mechanical energy change as the body falls down? What do you guys think? Okay, some of you are saying increasing, same. Excellent. I think Pravanjan has said no change, right? Niranjana is also saying no change in mechanical energy. Excellent. Because you know the sum of the potential and kinetic energy will remain constant. Law of conservation of energy, guys. Very important. Using law of conservation of energy. And so the mechanical energy, which is basically PE plus KE, is going to remain constant, or we can say the mechanical energy remains constant, right? So if it remains constant, the graph is going to look like a straight line parallel to the x-axis. There is no change. Very good. Hema Srinivas says the correct thing, right? Because we are using the law of conservation of energy. So very interesting question here, that it will remain flat. Of course, potential energy will decrease here, kinetic energy will increase, but if you add them up, they will remain constant. Let me try to draw it a little more parallel, right? So it will be hard to draw on a tablet, guys. So yeah, so it will be a straight line parallel to the x-axis. Why? Because the sum of the potential and kinetic energy remains constant. Why constant? Because by law of conservation of energy, potential is changing to kinetic, but they will add up, because by law of conservation, energy can neither be created nor destroyed. It changes from one form to the other. So mechanical energy of this body is going to remain constant. Clear? Awesome, guys. Awesome. And so wishing all of you a very happy new year again. And as I said, guys, do check out the courses on our website. They are at this big new year discount of 80% off for physics, chemistry, maths, and computers. I put the links below. And as I said, the offer is only valid for 3 more days. It expires on 10th January. And do share our website with your friends if they're interested in taking the courses. I know many of you have taken it already. So wishing you a very, very happy new year and all the very best for your exams. So guys, keep the momentum going, keep preparing, and I'm sure you guys will do well. And please do share out our YouTube channel. And if you guys haven't hit the subscribe button, please hit it right now. Hit the notification bell so that you don't miss out on any videos or live classes. And do share it also with your friends. Big thanks from all of you for all your love and support. And yes, I take live classes on our, so what do we have on these courses? Basically, we have more live classes that you can attend, right? Because I take live classes on the concepts, and we are having these important mock tests, you know, to help you prepare for your exams. We are taking regular mock tests every week on the different subjects. We are having mock tests. So you're basically, if you're taken the 3 subjects, you're having a mock test almost every week or 2 times a week also. And we are taking live classes to help you with the solutions, your doubts, the quizzes, right, the questions and the tips and tricks. And we have lots of questions on the website for you to practice. And you can also ask doubts. So you can send us your doubts as well. So all these good features. And as I said, as you can see, our New Year offer, it's on a big 80% off for a limited time. So guys, do check the website links below. And if you haven't hit the like button, please hit it right now. Wow, this is a record breaking 880 likes. And this is all thanks to all of you. So thanks a lot, guys. Yes, we'll soon be launching courses for class 7 and 8 as well. So I know some of you are in class 6 and are soon going to be going in 7, 8. We'll also be having those courses. But if you're interested in these also, you can take a look at the course topic and see. But right now we have courses for class 9 and 10. So awesome, guys. Hope you enjoyed this, and wishing you and your family a very happy new year. I'm sure you guys will do well. Have a great year ahead. And don't forget to subscribe to our YouTube channel and hit the like button and the share button. And also do check out our website. It's manochaacademy.com. I put the links of the website and the courses below. Yes, I'm from Kolkata, India. So yes, I'm from India and I stay in Kolkata. So thanks a lot, guys. It's great to hear all your feedback and comments. So thanks a lot for your love and support. And do put the comments, on what other topics you'd like. Wow, over 900 likes. Thanks a lot, guys. You guys were really awesome today. And I really enjoyed this class. Hope you enjoyed it. So this is Sandeep Manocha signing off. Take care. Have a great day and have a great year ahead. What's my name? Sandeep Manocha. And thanks a lot, guys. Structure of atom, you can search structure of atom YouTube. I think there's a video on that. Structure of atom Manocha Academy, you can search. Lenses, you can search for concave and convex lens also, right? Yes, and we have more videos on so the complete course is covered on our website. You can take a look at that as well, guys. All right. Thanks a lot. Good night and take care and Happy New Year once again. And do subscribe to our channel. Thank you, guys. Bye.